Hi everyone, welcome to today's video on complex numbers. We have seen that in order to solve this equations like this one will give us x is equal to 3 over 4, this one will give us s is equal to minus 3 over 4, while this one will give us x is equal to plus or minus root 2. Solution of this type is called a rational number, while solution of this type is a negative number, and this one is an irrational number. So these types of solution constitute the real numbers. They are found in the real numbers, so that if you have a number line 0, to this side is negative, y to this side is positive, and among the positive you can have let's say 1, 2, you can have root 2, let's say root 2 1.142, root 2 2 1 0, minus 1 minus 2, and so forth and so on. You can have e is 2.7 something, let's say here is 3, you can have here e, so here is 3. You can have pi 3.142, you can have pi. These constitute a set of real numbers. But sometimes there are times when we are confronted with equations like this: x squared plus 9 is equal to 0, so that you see that x is equal to square root of minus 9. It's usually not easy to find the square root of this, but in complex number we try to resolve it by saying 9 times minus 1, by calling minus 1, square root of minus 1 equal to I, so that I squared is equal to minus 1. If we don't do this, there will be a breakdown of our ways of solving this type of equation. So if we now go back to this our equation, you find out that x now is equal to square root of 9 times this one will now be I squared, so that we have plus minus 3i plus minus 3i. That is the solution to that type of equation. Now let us quickly run down the techniques in complex numbers. Techniques in complex numbers. One, let me do it in form of example. Let a is equal to 2 minus 3i and b is equal to 1 plus 3i. Let that be, so that if we want to do addition or subtraction, addition and subtraction, subtraction, if we want to do it and we say a plus b, so we are going to add. This one is the real part of this number, while this one with I is called the imaginary part. Imaginary part, real part, imaginary part, real part, imaginary part. A number can have only a real part, that means this one is 0, and it can have only an imaginary part, that means the real part is 0. So if you want to add this, you add the real to the real. 2 minus 9i plus 1 plus 3i. So you have it to be this plus this 3, this plus this 0. So the answer is 3. So if we do a minus b, we will have the same thing, 2 minus 3i, if you like, minus 1 plus 3i. So you are adding the real part so that we have you are subtracting the real part. 2 minus this 1 minus this minus this, because minus times this is minus, so it is minus 6i. So this is the answer in the form of complex number 1 minus 6i. Okay, let us quickly look into another type of equation. Let us say we want to do a cube. A cube is just 2 minus 3i cubed. So we can use Pascal's triangle. Remember in our video in Pascal triangle, 2 1 1 3 3 1. So it's the third one. So we'll just say 1 is equal to 1, the coefficient 1 into 2 raised to power 3 minus 3i raised to power 0 plus 3 2 raised to power 2 minus 3i raised to power 1 plus another 3, this one, 2 raised to power 1, then minus 3i raised to power 2, so that their component will be equal to 3. This plus this 3, this plus this 3, and the last one is 1 into 2 raised to power 0 minus 3i raised to power 3. This is 3i raised to power 3. So that we'll have it to be, this is 8. 8 times 0, 8. This is 8. Plus this one is 4, 12, 36 minus 36 minus 36i minus 36i. This one is 8. 8. This one is 36 minus 36i plus this one is 2 times is 6 times 9, 54 into I squared plus this one is 1 times 1, but this one is minus 27 I squared times I. I'm breaking it down. I squared times I is I3, so that we have 8 minus 36i. This one is minus 1. This one is minus 1. We have shown it before, minus 1. So it will be minus 54. This one is minus 1, 2. Minus 1 times this is plus 27. Plus 27i plus 27i. So that will give you minus 46 minus 9i. 46 minus 9i. Also, let us look at a over b. A over b. A over b will give us 2 minus 3i all over 1 plus 3i. So in order to do it, you find the complex conjugate of the denominator. The denominator is 1 plus 3i. The complex conjugate is 1 minus 3i. Just changing the sign of the imaginary part. You use it to multiply both the numerator and the denominator. And if you do that, you get is equal to you multiply this with that, and so forth. So you get 2 minus 6i minus 3i plus 9i squared all over. This one will give you 1 minus 1, because you go 1 2 first. 1 minus 3i plus 3i minus 9i squared. That will give you this plus this. This is 2 minus 9i plus 9 into minus 1 all over This one will cancel this 1 minus 9 into minus 1, so that you have that this is minus 9 plus this minus 7 minus 9i all over this, and this is plus 10, and it is minus 7 over 10 minus 9 over 10i, so that if you are asked to represent it in the form of x, I, y, is equal to this, is equal to that 10i, you find that x is equal to minus 7 over 10 and y is equal to minus 9 over 10. Minus 9 over 10. That is how to do it. Thanks, and please subscribe. Also click the notification button so that whenever we post new videos you will see it. Solo this is the YouTube channel. Bye.